Now, special right triangles are your 45, 45, 90 triangles and your 30, 60, 90 triangles. They are right triangles. This picture right here kind of displays that, kind of shows you what I'm talking about here. You can see the 45, 45 degrees, and then here's your 90. Now on these triangles, this is an isosceles triangle, so you notice both of these sides would be x. Alright, if the base angles are congruent, then the sides are congruent. Now, back from your geometry days, that makes this length of the side x times the square root of 2. So if these are 5s, this is going to be 5 square root of 2. If this is 10 and this is 10, then this is going to be 10 square root of 2, and that's how long that is. Those are nice because you don't have to use the Pythagorean theorem to figure those out. So if you remember that and you remember your teacher discussing that in geometry, then great. Otherwise, we will cover that again later on in a section that we do later on this semester. So if you're not sure about what I'm talking about, go ahead and get the notes down so you'll have them, and then we'll cover those again later. Again, here's the 30, 60, 90 triangle. I tell my students their favorite leg is the short leg, which of course is opposite the short angle. So since this is the 30, then this would be our favorite leg, because it's going to be the short leg. Everything stems from the short leg. If this is x, then this is double that. So if this is 5, this would be 10. If this is 5, this is going to be 5 square root of 3. You just tack a square root of 3 by it, and that's how long this side is. So once you know the short leg, you know both of the other sides of the special right triangle 30, 60, 90. So let's practice. If this was 3, then this would be 6, because that's 2 times 3. If this is 3, then this would be 3 square root of 3. Alright, well anyway, that is just a brief, very brief overview. It takes at least a week or two to teach that in a geometry class. So if you weren't sure about that, then that's fine. We'll go over it later. Alright, geometry continued. These fairly simple, straightforward formulas. You've got area of a rectangle, length times width, area of a parallelogram, base times height, area of a triangle, 1/2 base times height, area of a trapezoid, 1/2 the height, times the bases added together. And the last one is area of a rhombus. It does have 2 possibilities. You can treat it like a, this formula is wrong. It's actually area equals base times height, like a parallelogram. So do not put this 1/2. Alright, that is a typo. And then this one is correct. Area is equal to 1/2 diagonal 1 times diagonal 2. So that just means you can find the length of the diagonals of the rhombus, multiply those together, and divide by 2, and that will give you the area of a rhombus. So hopefully you caught that in this video, that this formula is wrong. Scratch that out and just put base times height. Alright, this is the just a few more various formulas you should know. A kite, area is equal to 1/2 the diagonal 1 times diagonal 2, very similar to the rhombus. Area of a regular polygon, regular means, remember that all sides are the same length. So if it's equilateral on the sides, then you're going to have 1/2 the apothem times the perimeter of the polygon. So if you don't remember what an apothem is, of course you can Google it. It's A-P-O-T-H-E-M. Apothem. A-P-O-T-H-E-M. So you can look that up, or we'll try to cover that later on in the semester. Circle, area is equal to pi r squared. Gosh, we've got to have that one memorized. Circumference is pi times the diameter. Or you can take 2 pi r. If your teacher taught you that in geometry, that's fine. I don't care if you use the diameter or the radius, but it's basically the same thing. Pi times the diameter. Arc length is how long the arc is on a circle, just part of a circle. So of course you're going to take the fraction of the circle times the circumference. So it's n over 360 times pi times the diameter, which of course is the circumference. So you just use the fraction of the circle you need. If you're looking at a 45-degree angle, you'll put 45 over 360. We'll practice that later. Sector area is the same thing. The degrees over 360 is equal to pi r, or I'm sorry, multiplied by pi r squared. That will give you the fraction of the circle that you need. It's all like eating a piece of apple pie. You're taking a sector out of that apple pie. All right, trig ratios. This is your basic geometry. When we're using right triangles, we can find the angles, the angle measurements of those right triangles. They can use this to find the sides. It's just helpful when you don't have enough information to use the Pythagorean theorem. Or maybe you have different information. You have angles instead of sides. So just to review, sine is opposite over hypotenuse, cosine of the angle is adjacent over hypotenuse, tangent is opposite over adjacent. Most of you will probably remember your teacher saying SOHCAHTOA. That's what that is. All right, these are trig identities. I am not even going to sit here and discuss these. There are a few people that have had trig or are taking trig right now that will understand this, or maybe you haven't even gotten to it yet. So there's no sense in me covering this material with you at this point, because most of you, I would say, don't know what this is, and if you have not taken trig or you are in trig right now, I'm sorry, let me rephrase that. If you have taken trig or you are in it right now, then you're going to want to write this down. If you have not taken trig, maybe you've just finished through Algebra 2 or are taking Algebra 2 right now, then you do not need to write that down. This is the same thing. These are for my trig students or people that have taken trig, calculus students. They will understand this. Just to kind of review, to graph the sine wave graph, A represents the amplitude. Remember, that is, the amplitude is basically how tall this thing is, how high up and how low it goes. The period B, capital B, helps calculate the period. That basically shows how long the sine wave is from start to end before it starts repeating. C represents the horizontal phase shift, which means you might take your sine curve and you might shift it on the x-axis left or right a certain amount, and this will tell you how far to shift it. And then D represents, up here, this represents the vertical shift. This might take your sine wave and make it up. It might shift it up 2 or shift it down 4. It just kind of depends on what this D value is. If you're not taken trig yet, you can ignore that. All right, degrees to radian conversions. If you're going to convert degrees to radians, you're going to take the number of degrees and you're going to multiply it times pi over 180. Okay, notice the degrees will cancel here. So since pi is equal to 180 degrees, it's basically a trig calculation. That's why those degrees are marked here, so they can cancel out and you have your answer left in pi, which is in radians. All right, sometimes our calculator accidentally gets in radians, and I have students all the time going, my calculator's not giving me the right answer, and so I say, oh, you've got it in radians instead of degrees, so you need to switch it back. If you're going from radians to degrees, then you want your radians to cancel. Okay, so your whatever radians you have, if you have 5 radians or 5 pi, then the pi's would cancel and then you just multiply it by 180. So anyway, if you've covered this before, then you're going to know, or you're going to remember, that's going to look familiar to you. All right, logarithms is for anybody in Algebra 2 at this point. This is how you calculate exponents. Log base b of x is equal to c, and you can rearrange that to find out your exponent. B of c, this is your base, and notice your base is right here, and this is always your exponent. So b of c is equal to x. You just need to know that rearranging. It's like a puzzle. Okay, you need to know how to rearrange that. If you have log base b of a product, x times y, then you could take log base b of x and add that to log base b of y. That helps you simplify your logarithm. And then this is the property of division, log base b of x over y. That's equal to log base b of x minus log base b of y. Hopefully you'll have seen that before, and if you haven't seen that before, then don't worry about it. All right, these are conic sections, and from just the past, there's very few of these that people even know. Okay, maybe these first two you've seen before, but the last two I think we haven't taught in this high school a whole lot, so we'll cover those a little bit later. But for now, if you want to go to just write this all down, you've got your circle equation, which you studied in geometry. Remember, the r here is the radius, and the h and the k are the center of the circle. Okay, don't forget that. Here's your parabola equations. This is in vertex form. Okay, this is a smile parabola. This is a it's a smile or a frown. I'm sorry. Remember, if the a is negative, it's going to go down. But this one goes left and right. This is kind of your horizontal parabola. It looks like a C or a backwards C on the graph. So when you have your x out here instead of the y, it kind of flips the parabola so that it looks like a C rather than a smile or a frown. And then your ellipse and your hyperbola equations, if you'll just want to jot those down, make sure you have those, so that way, let me scroll this up a little bit so you can see it better. So that way you'll have those in your notes for later if we have time to go over them. All right, guys, that is it. So hopefully you got that all down, and I know that was a lot, but please do not fret, as that was 4 years worth of mathematics in less than 30 minutes. So hang in there, and we're going to start covering all that stuff little by little. We've got an entire 16 weeks to get it done. We'll see you soon.